Okay, one property of the central force motion is law of equal areas. Okay, for any central force, R shapes equal areas in equal time. Okay, actually it is a consequence of constancy of angular momentum. Okay, let us understand in this way. So this is our coordinate and this is our R. After some time delta t, theta becomes delta theta and R become R of t plus delta t. Okay, I have drawn in this way here. So this is R. I have drawn a perpendicular to this one. So this is R. This is delta R. So that this to this R plus delta R, delta theta, and this is R into delta theta. Okay, this perpendicular. So that I assume this delta theta is very small. So I can think that this is a triangle of base R plus delta R and altitude R delta theta, like this. R plus delta theta is the base and R delta theta is the altitude. So therefore the area of the triangle is delta is equal to half into base into altitude, half into R plus delta R into R delta theta, that is half R square delta theta plus half R delta R delta theta. What I want is I need the rate of change of area, or the how much area seeps out in time t. Okay, that is dA by dt. It's given by limit delta t tending to 0 delta A by delta t. So that is given by the limit delta t tending to 0 half into R square delta theta by delta t. Substituting here, that's all. Into limit delta t tending to 0 half R into delta R delta theta by delta t. Okay, here what is R into delta theta? That is area of the small triangle with the side delta R and R delta theta. That will not contribute in the limit delta t tending to 0. As delta t tending to 0, delta R is negligible, so it will not give any contribution. So therefore only this time contribute, and it is given by half into R square d theta by dt, where d theta by dt is limit delta t tending to 0 delta theta by delta t. Okay, so therefore dA by dt is half R square d theta by dt. Now let us understand the velocity. So this is the mu r theta, this is the radial velocity, radial component of velocity, that is r dot, and this is the tangential component r theta dot, this is actual velocity. Okay, so the angular momentum L is equal to r cross p, r into r cap into mu v, where we have radial and tangential component, that is r dot and r theta dot. So these are in same direction, that will cancel. Mu into r cap into r theta dot, theta cap will exist, that is mu into r square, r into r square theta dot into r cap cross theta cap exists. R cap cross theta cap is direction perpendicular to both r and theta, that I take k, that means in the z direction. Okay, a perpendicular direction. So r cap cross theta cap is k. So actually the z direction means the z component of L, that I call Lz, is equal to mu r square theta dot. Okay, so from that I have theta dot is Lz by mu r square. Therefore dA by dt is half r square, theta dot is replaced by Lz by mu r square. This r square and r square cancel, therefore I get Lz by 2 mu. Okay, so Lz is a constant for any central force, and mu is a constant because m1 and m2 is constant. Therefore dA by dt is constant. That means in any central force R will shapes equal areas in equal time.